Alright, hi grade 12s. I'm going to just sort of pick up from where I left off. So we were looking at functions and their inverses, and we looked at what happens graphically and also what happens algebraically. So just a reminder, graphically the two graphs are reflections of each other around the line y equal to x, and that explains why algebraically we interchange the x and the y, because the coordinates interchange when you reflect over the line y equal to x. Okay, so we looked at a straight line graph and its inverse, and then we also looked at this parabola and its inverse. Okay, now you may have come across her on the video talking about one-to-one and one-to-many and so forth, and I did quickly mention to you in the previous video, it just means one-to-one function means for every one x it's going to one particular y value, and but then in this particular case over here I just want to mention that although, for example, let's just take minus 2 goes to 4 and 2 also goes to 4. So although you've got two x values going to one y value, the important thing is it's going to one y value, and that's why it's still a function. In the red graph you've got an x value which goes to two different y values. So you can have two different x values going to one y value, because for every x there is one y, that's a function. But here, if you have an x value that goes to more than one y value, then it does not become then it's not a function anymore, right? So that's just what one-to-one, and then this would be one-to-many. This would be a many-to-one, 2 minus 2. Minus 2 goes to 4, and 2 goes to 4. Okay, so that's just what that sort of notation means, in case you were wondering. The parabola, we basically took the y equal to x squared, and then I drew this on autograph, but if you were having to actually do the inverse function, as long as you can draw the original function, plot some points and see what the graph is doing, you can always then sketch the inverse by just interchanging the coordinates. So I'm going to take something and I'm going to just work through something with you. So let's say, for example, I take a graph which is something sort of arbitrary. I think she did something similar in her video. I think the second video, but I'm just going to show you so that you can see how we work through it quite easily. So I take something like this. You don't really recognize this as such. It's not a straight line, it's not a parabola. So let's just start off by saying, okay, well, what is this telling us? Well, we know that the number under the root sign has to be greater than or equal to 0. You can't have a negative under the root. So that means that x must be greater than or equal to 1. So my domain, remember x describes your domain, is all values of x that are bigger than or equal to 1. So 1, 1, 0, 0, 1, 1, 5, all of those values could be part of the domain. To just get an idea of what this graph is going to look like, I'm going to choose some nice values for x. Obviously they have to be bigger than or equal to 1. So let's choose 1 itself. So I'm now talking about, let's call the function f, alright? So what would my points for f look like? Well, if x was 1, then 1 minus 1 is 0, y would be 0. If x was equal to 2, y would be equal to 1. I'm not going to choose x equal to 3 because root 2 is not a very nice number to work with. Same for x equal to 4. The next nice value would be x equal to 5, and then it would be root 4, so it would be 2. Okay? And notice it's not plus or minus the root, it just says the positive root of x minus 1. Okay, let's have a look if I plot those points. Here's the point 1, 0. Here's the point 2, 1. And here's the point 5, 2. And so my graph would be looking like that. I can't go extending here because x has to be bigger than or equal to 1. Now, obviously, if I want to draw the graph of f minus 1, well, let's just look and see what's happening algebraically. Algebraically, we interchange x and y. Okay? And then we're going to square both sides because we want to get rid of that root. and then I want to write it in the y form. So y would be x squared plus 1, or if you like, make y the subject on the left, and that is my inverse function. But at this point, I would be able to see that there is a restriction on y, and that in actual fact, from here already, I would know that y minus 1 has to be greater than or equal to 0, so y would be greater than or equal to 1. And that makes perfect sense, because remember we said the domain of the function becomes the range of the inverse. So here x is greater than or equal to 1, interchange x and y, so in the inverse y must be greater than or equal to 1. So I choose, but now I don't even have to choose, because I know that when I've got a function, to get the inverse, I just simply swap, interchange my coordinates. So my coordinates for the inverse function would become 0, 1, I interchange 2, 1 and 2, 5. So all I've done is I've taken the 3 coordinates there that I worked out for f, and I've just interchanged them. So now I can plot those 3 points. 0, 1, 2, 1, 2, 1 is over, sorry, it becomes, 1, 2. So 1, 2 is over here. So 1, 0 became 0, 1, 2, 1 becomes 1, 2. I've plotted that. And then 5, 2 becomes 2, 5. Okay. And so there's my 3 points over there. And the graph is going to look something like that. Okay, continues up there. And if I had to draw the line y equal to x, sort of going through here, you can clearly see that this is the graph of f, this is the graph of the inverse, and the one is a reflection of the other one around the line y equal to x. Now I didn't use any sort of special maths techniques or processes here. I simply just worked with my general knowledge, knowing that the number under the root sign must be greater than or equal to 0. I generated 3 sets of coordinates for the function. As soon as I've got the coordinates for the function, I've immediately got the coordinates for the inverse function by interchanging when I work with the inverse function. And now I've got my points, and I can plot my points. Be careful you don't just extend it, because remember y has to be greater than or equal to 1 here, and x greater than or equal to 1. So I've managed to actually graphically sketch these 2 functions here, the function and its inverse, just by kind of figuring out and using my basic maths knowledge. Alright, and clearly graphically you can see the one is the inverse of the other. It's reflected around the line y equal to x. Don't forget, when you start off with a function f and you want the equation of the inverse, first step interchange, but then you must get it back into the y form. Okay, hope that's made sense to you.